All right, so good afternoon. It is officially the stroke of 3 p.m. And I'm Vito Genovese, and I'm going to be talking about Capture the Flag and Owner's Manual. So first of all, what is Capture the Flag? Capture the Flag is like the catch-all term for computer hacking security competitive games. Whenever I think of Capture the Flag, the scene in The Social Network where they're talking about, oh, we're hiring interns based on how they can hack this other team's Apache web server, and it shows like 4 interns around a table trying to hack each other. That's a Capture the Flag game. There are a lot of Capture the Flag games going on. I checked CTF Time, the website, this morning, and there's 3 coming up this week before next weekend when I run one, or when I help run one. I'm a strong proponent of Capture the Flag games. A Capture the Flag game will teach you a lot of things that aren't necessarily just computer hacking. They'll teach you a lot about how you work whenever you're like working under stress or trying to solve a hard problem, or whenever your friend just solved a hard problem and you're celebrating. They'll teach you a lot about your tolerance for caffeine. They'll teach you a lot about what happens whenever you don't sleep. They're very, very... if anybody wants to improve me at computers. So if you want to try a Capture the Flag game, I can strongly recommend the Command and Control Capture the Flag, which is going on literally right now in the other room. They've been offering beers and mojitos, and I'm not going to talk about how many I've had. My friends and I, with Legitimate Business Syndicate, are running the qualifiers for DEF CON Capture the Flag next weekend. You can register at legitbs.net. Yeah. And our finals game will be August 5th through August 7th at DEF CON in Las Vegas. This is a shot from last year, sort of towards the end of our game. And I'll talk a little bit more about DEF CON Capture the Flag as we go on. So we consider DEF CON Capture the Flag to be the best of the best. We start with 1,400 teams or more from around the world. After qualifiers, we whittle that down to 15 teams this year. And from our finals game on site in Vegas, we produce 1 winner. The winners for our game are generally considered to be the best in the world. On the left, you have the 2015 CTF Time standings. And on the right, we have our final standings. And all those ugly fuchsia lines are just sort of the correlations. There are very few teams that do well in our game that aren't the best in the world. And there are very few best in the world teams that don't play our game and do very well. So for us, our main challenges as running the game aren't how do we hack better, it's how to build a better game. And our process for building a good game involves engineering a game that's not frustrating for players. It involves operating a game that's reliable, and again, not frustrating for players. And finally, it's about having the empathy to make the game fun and make sure that it all goes smoothly. So let's talk about the engineering first. Engineering is a process. It's iterative. You go through, you figure out what the problem is, you come up with a possible solution, you see if it works, and you do that over and over and over again. And there's not going to be a quiz, so please don't memorize that slide that's not on the screen. For competitive formats, we tend to see normally 2 formats, but there's a new format being introduced this year. Jeopardy, attack, defense, and the new one is consensus evaluation. So Jeopardy-style Capture the Flag games, they're almost exactly what you think. Up here we have the Kenshoto qualifications game from 2007. We have 5 categories that are, some of them are named after the SNL Celebrity Jeopardy categories. And as you solve questions, you're able to go down 1 more in the category. You solve a question, you get a point, and in the case of a tie, whoever solved the last question most recently loses. Running Jeopardy games is actually pretty easy. You build a scoreboard and you build a lot of challenges that are standalone. When I say standalone challenges, I mean players connect to the challenge, they do something, and they get a flag that they redeem to the scoreboard and get points for. Players generally, unless that's actually the challenge, don't have to do any complex networking. There's no VPNs, there's no VLANs. They just connect to a website and then connect to these other servers that are hopefully still running because Amazon hasn't turned them off. We actually have to warn Amazon whenever we're running services on EC2. So On the other side of Jeopardy is attack defense games, which are much, much harder. They involve a complex networking setup. Every online attack defense game I've seen has completely relied on OpenVPN to actually connect you to the game network. Once you have that, you have all this like connectivity sensitivity and other rhyming things. If your connection is weak, you're not going to be able to attack other teams very effectively. If the teams are hosting their own service, a team can have a perfect defense by bringing their service down or having a flaky connection. If the organizers hosting the services, now if teams don't have a good connection, they may not be able to score on other teams. If services get slow or unreliable, that hampers the ability of the scoring system to make sure the services are still working, and it hampers the ability of other teams to score on these services. And I'll get more into that later. There's also Superman defenses, which are ways to make a service impossible to own, that are good, like really, really good to use in production of actual services, but really, really terrible for capture the flag games. And of course, there's our good friend metagaming. Finally, the new format this year is called consensus evaluation. DARPA, the DoD Advanced Research Projects Administration, you may have heard of them from Metal Gear Solid, are running the Cyber Grand Challenge this year, the day before our game in DEF CON. And what the Cyber Grand Challenge is it's 7 autonomous computers that take a broken or a binary as input and produce a patched version of that binary and a attack program that will exploit this binary, or to use their euphemism, will prove a vulnerability in this binary as output. It should be exciting, and there's a lot more to be said about consensus evaluation, but we also don't completely understand it. It's a brand new format, and it'll be interesting come August to see how it works in production. Once you've sort of chosen the format for your Capture the Flag game, you have to think about theming. And theming can be easy, and it can be hard. And theming, for us, first of all, it's kind of a lot about the visual design and the aesthetic of the game. A lot of these formats, like banking, Stuxnet, money laundering, SCADA, those all come from the Shellfish ICTF game run by UC Santa Barbara. Generic hacker is a very, very popular format because it means a black background with green text. But the other side of theming is what kinds of challenges you'll have. The standard categories we see a lot of are web, crypto, forensics, reverse engineering. I didn't actually have space on the slide to write reverse there. Programming, so like ACM programming competition style challenges, and challenges about writing good shellcode, or writing shellcode with very, very specific constraints. We tend to run a very, very specialized game for this. We've sort of de-emphasized web and crypto, and we've never run a forensics challenge because the Legit BS team, we're good at reverse engineering, programming, and shellcode. That's not to say that a generic Capture the Flag game doesn't have value. It's that it has value, but we can't do it well enough to bother trying. Once you've figured out what kind of game you're running, you have to think about scoring. And for scoring, we are completely dependent on SQL, the database language. And my general SQL rules are normalize as much as you can. Go to like the highest practical normal form. I'm pretty sure that's in your textbook, HPNF. We index everything we can. I may have been part of a Capture the Flag game in 2007 that didn't have indexes, and it took us literally 3 hours after the game was done before all the captured flags were finally finished processing. So if you remember nothing else for running a production service, remember indexes, please. And then finally, we write a lot of constraints. And this is something that's bitten us before. In, I think, 2014, one team, I'm pretty sure it was Men in Black Hats, came to us saying, what happens if you score on yourself? So if you're running a service and you try and score your own flag, and it turns out that we didn't have a constraint to prevent that, and I'd never tested that, so I couldn't give them a satisfying answer. That's a lot of what I do, is not give satisfying answers. So for Jeopardy, scoring is super easy. You run this query every time somebody refreshes your page. Attack defense scoring is, it's so complicated, because attack defense is a complicated game. So for attack defense, I normally start thinking of 3 distinct parties. At the top, we have the scorebot that we run. On the left, we have PPP's, or the Plaid Parliament of Poning's instance of the service called @mail. And at the bottom right, we have Shellfish, the UCSB team. At the beginning of every round, our score bot deposits a flag in PPP's @mail instance. At some point during the round, Shellfish is going to attempt to, and we'll assume they succeed, steal this flag. And that's usually by submitting some bad input to shellcode or to @mail to make it spit out a flag over the wire. Or if PPP's been paranoid, to spit out an encrypted flag over the wire. Once Shellfish has this flag, in order to get credit for it, they redeem this flag to the score bot. And at the end of the round, they get points for that redemption. At some point during the round, the score bot has to check and make sure that PPP hasn't broken their @mail service. So if it works fine, if we're able to say, log into @mail, read some messages, save some messages, make sure they got saved correctly, they don't lose points for breaking @mail. If PPP does break @mail in this case, we have a problem. Not only are they failing their availability check, but there's a chance that by breaking @mail, they're making it impossible for Shellfish to score. This is what we call a great defense. If you get a fail whale on Twitter, you probably can't hack Twitter right now. The problem is that it also doesn't work, and a big part of security is availability. And there's a lot of metagaming to be done there. And metagaming is whenever you quit focusing on beating your opponents in a game and start focusing on beating the rules of the game. One popular metagame is this difference between downtime or being hacked. And taking a service down does mean you can't be hacked, but it's also not fulfilling, some service level availability or other constraint that we have. So in 2013, Cyphertex, Jordan Wines, he won a bunch of miles from United for hacking them a few months ago, asked us straight up, if your service is down and you lose 19 flags, but they get split evenly among your competitors, is that better than being up, keeping all your availability flags, but losing 19 flags to PPP, who ended up winning that year? And going by my knowledge of the scoring algorithm, because I wrote it, somebody thankfully cut me off before I gave him the real answer, and I was just, they pulling me away by my arm, and I'm saying, wow, that's a really good question, see you later. So the correct response for that is maybe make your scoring system super penalize people to make being down way more painful than just being hacked. Another thing we see quite a bit is a technique called reflection. So whenever you attack a service over a network, the attack produces traces or packet captures. And if you can reflect an attack, that makes you a very, very dangerous team to attack. It means that not only can you see how you're being broken and improve your defense, it means that you can use this attack that you've now witnessed to attack other teams to dilute the first mover advantage on attacking any given challenge. So there's an interesting game theory, game you can play with that. You figure out, maybe I shouldn't attack PPP with this brand new vulnerability because then they'll understand it. What we've also done is start using Diffie-Hellman handshakes and encrypting traffic so that even though PPP sees all the traffic, they can't just reflect something off the wire. And incidentally, they said PPP doesn't actually reflect stuff. They're just really, really good and have a lot of people. And I think GeoHot plays with them sometimes. Well, I know GeoHot plays with them sometimes. And then finally, the biggest thing is having first blood on a service. So again, tying in with reflection, if you're the first team to hack a service, you have to think carefully about who you attack with it so they don't turn it around and dilute your advantage. But you don't want to but you also, if other teams know it can be hacked and they know it can be hacked very quickly, they're likely to start reevaluating some assumptions. And how you choose to reward first blood, whether you want to just give them a whole bucket of first blood congratulations points or include it more organically in the scoring algorithm, is a really, really hard choice to make as an organizer. So for our attack defense scoring, we've traditionally always been zero-sum. So each team starts with a finite number of flags, and there's only so many flags in the whole game. In our 2015 game, each team's service started with 1,337 flags, which I guess is some significant number in hacker culture, I'm not sure. And whenever somebody stole flags from the bad logger service, it meant that those flags stayed with the bad logger service. So if DefCore got completely hammered on, actually DefCore did really well. So if Men in Black Hats got completely hammered on Service X, it was still like you couldn't steal anything from Service X on them because they didn't have any more flags. But whenever Service Y opened, you could totally take their flags. So it meant that there wasn't this, like eventually during the game, if you don't box these flags per service, it means some teams are no longer worth attacking, which hurts the game and it hurts people on those teams, and it kind of hurts attackers too. It means it does force the teams that do well into an interesting corner, but there's definitely a trade-off there gameplay-wise. So whenever a team gets owned in our game, they lose N-1 flags. So in a 15-person game, they lose 14 flags. The flags get split evenly among the stealers. If one team steals all their flags, that team gets 14 flags. If 5 teams steal their flags, each team gets 2 flags, and the 4 flags that are remainder, we hold on to them and redistribute them among every team that scored on that service against anybody at the end of the round, which is really confusing. In 2013, the first time we ran finals, we actually forgot to do that part, and on the database side, Legit BS won the game because we got all the remainder flags and just never gave them out. But we also didn't get black badges from that, or leather jackets or anything, because you don't get to win when you run the game. It's kind of sad. So whenever you have downtime, that means that people can't steal from you, and we really, really hammer you for downtime. Instead of losing 14 flags by being hacked, you lose 28 flags, and also if you were partially down, another team could steal another 14 flags from you. See the potential of losing 42 flags per round if you were partially down and also owned. So don't be down, and definitely don't be owned. Whenever we had downtime flags and remainder flags from being stolen, we split those evenly among all the teams that scored on that service. Once you have the scoring algorithm nailed down, you have to really, really think about the meat and potatoes of capture the flag, what challenges are, and what challenges you're building. And there's definitely a science to building a good challenge. It comes down to thinking of a cool bug, so it can't just be, buffer overflow without any stat canaries on, no ASLR. Think of cool bugs that are fun to hack and fun to figure out. Write these bugs and a tool to verify that the bug is actually landable. Once you've got that, you start wrapping the bug in more analysis surface so the bug doesn't pop out of a too small binary. As you're building this analysis surface, you should also probably improve your tool to make sure that your bug still exists. And then finally, and this is super important for Jeopardy games, write a smoke test to make sure the service still works and is still hackable. Besides the science, there's also an art to challenges. It's a difficult thing building a CTF challenge, and it's like one of those things where you sit down at your computer on a Monday morning and you open up your text editor, like Emacs, if you're cool, VI, I guess, or Sublime or whatever, and you say, okay, I'm at the desk, now what? And you have to think about something fun that'll keep you interested in building the binary and will also keep teams interested. So what we like to go to is vulnerabilities of historic interest. So is a double free vulnerability that's just like incidentally a double free vulnerability super fun on Linux, or would it be a lot more fun in a like DOS protected mode program? Is a image decompression vulnerability more fun on Linux on ARM, or on a like embedded MSP 430 with its own GSM network or CDMA network? Those are real examples, by the way. Building challenges. Another thing to manage is difficulty of a challenge. And difficulty is like the best way you can control team size. If you go out and write a zillion challenges, that means that there's a huge advantage to just having a huge team. In 2010, I think it was Samurai that won DEF CON Capture the Flag that year. And it said, Samurai, come up on stage. And like 8 people came up on stage. And then 16 people were up on stage. And then Samurai was a 40-person team that year, if you don't count the other 40 people that were training with them at the same time. And if you put too many challenges in your game or have too many challenges at once going on, it really, really benefits a huge team with 40 to 80 people. we interviewed a bunch of competitors, and they said that their ideal team size limit was the number of people on their team. Most teams do have 10 people plus or minus 2. But you can control the advantage of a big team by having fewer challenges and making them harder. A bigger team isn't going to solve a hard challenge faster. A bigger team will be able to solve more challenges at once. If you pick a super hard challenge and only have 70 of these challenges released over the weekend, you really, really limit the utility of a big team. In quals, here's an example. So in our quals in 2014, the team that placed 5th place in quals is called Tom Cruise. And that was actually GeoHot playing alone. GeoHot normally plays with PPP, but that year PPP had already pre-qualified, and he kind of wanted to see how he could do without them. And down here, you can't even see it, but there's a big pink arrow pointing at where PPP scored in qualifiers that year. And there's definitely this huge MVP aspect to capture the flag games. The most important part of writing challenges is making them fun and making them reliable. A reliable challenge is the best improvement you can make for during the game. And that brings me to operations. My dream for operations is to just completely get demolished on rye whiskey and that sort of thing during the game, and maybe not be jerks to teams, because that would be bad. And I would never dream of doing that or calling them garbage on a PA. The most frequent questions we get during Capture the Flag are, is this service down or broken? And is this actually exploitable? So what we make sure to have is health checks running just for our benefit all the time, seeing, oh, this server is being DDoSed, or there's some memory leak in the service that just breaks everything. And being able to hit up and enter and see, nope, it's still exploitable, hack better. The most important part of operations for Capture the Flag is that really, for us, it only has to work for a weekend. We're starting our next game next Friday night. You should play. And we're wrapping it up next Sunday night. And we usually leave the services on for 1 extra day for any teams that were close but no cigar on something. But they aren't something super reliable that has to run forever. That said, we do start early. So for us, it has to run for more than a weekend. For next weekend's game, we've already started standing up services. Our scoreboard has been running for a month. A lot of our services are running now. And we have a lot of the scripting in place to start the services on the correct schedule. We use off-the-shelf server management stuff because it's practical and it works, and we don't have to learn it from scratch. Most of our stuff, except for the scoreboard, is all managed by Puppet. That means that right now we're all running in US East 1 on AWS. Right before the game starts, we spool up Southeast Asia and US or the Ireland data centers because it gives a better experience for players. And with Puppet, it's so easy for us to do this that it's almost not worth not doing that. Just running down some acronyms. Heroku, we love Heroku for the scoreboard. Chef, Puppet, we use Puppet, but please pick one of these and learn it really well. It's the future of operating computer services, or maybe the past because Docker exists now. Amazon EC2, it works. It's not that expensive, and it's a lot cheaper than owning hardware and hosting hardware and providing a network connection to hardware. And I typed Docker at the bottom, but I think I broke the file somehow. Running a Jeopardy! Capture the Flag game is really, really cheap. Boston Key Party, this year, they spent $27 on services, which is a tenth of what we spend on booze. We run in a lot more data centers than Boston Key Party and have more challenges, but it's still, only under $300 to host our game. And that leaves a lot in the third line there for the things that we want to do with Capture the Flag. For our attack defense game, because it's on site in Vegas, we bring hardware. This is our Creator CI20 MIPS Linux cluster. At the top right, it's kind of blown out on the projector, but it's like an off-the-shelf USB hub powering everything. The only complaint about this cluster was that it was super flaky when we were building it, and we didn't trust the USB hubs. But in production, it ran super, super well. This is our Raspberry Pi 2 ARM running Windows cluster. That's something we wanted to do for ever since we started running DEF CON, was getting up on stage and say, PowerShell into your Windows machine. And because the Windows licenses for these are free, and we could afford to have like 20 of them in one box, it was something we wanted to do so badly that we didn't realize how unstable it would be in production. Now, I'm not going to rag on if it was an OS problem. My suspicion may have been static electricity. We built and ran all these clusters in coastal Florida, where the humidity is basically rounding error from 100%. In Vegas, with all this moving air, this acrylic case, I don't know. I'm not an electrical engineer. So we bring hardware to Vegas. And the reasoning for that is we can run weird architectures. Our teams aren't going to have a MIPS machine to run a game on. Or if we tell them to, like, hey, you should totally bring a MIPS machine for unspecified reasons, they're going to understand the reason basically instantly. That said, if you do tell them to bring hardware, they may push back on it. A lot of teams travel from far away, and it's difficult for a Chinese or a Korean team to bring a lot of computers. US teams, they may bring computers, but whenever we started with ARM Linux in 2013, PPP only had one ARM machine, and it was a Chromebook, and it was a really, really underpowered $300 Chromebook. A few teams made fries runs and cleaned them out of ARM Chromebooks, and a few other teams just suffered with QEMU static and having it run slow. The other reason to bring hardware is normally you just don't trust the uplink. Who here's been on the Wi-Fi today? Does it work? Okay. I have not been on the Wi-Fi today, so I have no idea if it works. Did you log into your Japanese Department of Defense email over plain text, like in 2011 at DEF CON? We actually do. Every year we've been at DEF CON, we've had a really, really reliable wired uplink, and I've been posting on Twitter and doing that sort of nonsense over it, but we don't trust it for game reasons. On the flip mode, there are teams that do trust the uplink. At the Chaos Communications Camp in Germany, literally right after DEF CON last year, Stratamahur, the German, I think Berlin and one other hackerspace in Germany, they ran the CTF at camp, and only one service was hosted on camp. And this one service required proximity and RF and antenna design. And there's a really good talk by, I think, Duck, talked about how he solved the service, but it involved GNU radio and calculus, and those are not my jams. Shellfish brings a huge rack of servers this tall to DEF CON. I've always wondered what was in it. Giovanni claims that most recently they just bring it to look cool, but I don't believe that. This is our Raspberry Pi, our Odroid U2 cluster that we ran at DEF CON in 2013 and 2014. And the caveat with bringing your own hardware is that teams are really, really good at hacking stuff, and if you put them in a jail, they may find some, even in we were running them in LXC containers, and I think it was, my notes doesn't have it, but I suspect it was Shellfish or some team got really, really good at hardlocking their Odroid to the point where we thought it was a problem with hardware. And Salir, basically our god emperor of networking and physical infrastructure, has spent 2 hours just running back from his desk across the stage, down the stairs, around the corner to the servers, unplugging, replugging in their Odroid, going back all the way back and seeing if it works. And at some point during this, I'm stressing out because their server being flaky is hurting my availability checking and making the game, making the game run slow. And the way I asked just sort of set them off, and I can't fault them for that. The most important part of capture the flag operations isn't making sure your hardware works, it's making sure your team is working to run the game correctly. And he literally stormed out, and we're like, we've never seen this guy angry or stressed before. Is he going to go murder 10 people? But no, he's not Ted Cruz. He didn't do that. An important part of Jeopardy operations is timing service releases. So the idealistic fairy tale happily ever after version of Jeopardy services is you unlock one service at the beginning, and whoever solves it first picks the next service. there's problems there where if a team sees that some service is worth 6 points, they may never unlock that service because they don't want to not solve this super hard service first, or they may unlock it first to just ruin everybody else's time. So up here we have a service called DOS Fun For You. And we actually force unlocked this service because we wanted to see, well, 2 reasons. First, we wanted to see whether anybody would actually be able to solve it. And we also unlocked it at 2 a.m. local time because we knew nobody would solve it before we woke up from, sleep. And sure enough, this service took 19 hours to solve. And it involved the one write-up for this by Elwa Vanderberken goes into how they had to patch the IdaPro disassembler to handle this corrupt binary produced by the Borland Turbo C compiler correctly. It was a hard service, and we do not regret unlocking it so we can sleep. Attack defense service timing is also really, really important. On the right, we have a service called Badger, and that's the aforementioned MSP 430 image decompression vulnerability on a CDMA network. And we made sure to release that halfway through the first day of the game. We told all the team captains, attention teams, told them to come up to the front of the room. We gave them this hardware and an instruction sheet that says, keep it plugged in, keep the switch in the run position unless you want to lose points. And with all that, we gave them that Friday afternoon. Nobody scored on that service until the last round of the game, Sunday afternoon. But we also run into an issue with a typical service problem. PPP had this service ostensibly solved, but there was an off by 1 error, one of the 2 big problems in computer science, in the software running on there, and they could not write shellcode that would return flags to them. And I didn't find this out until the next day after the game was already done, and PPP already won. Anyway, so who cares? Service timing in attack defense is about player time management. The general recommendations are that DEF CON attendees take 1 shower, have 2 meals, and 3 hours of sleep in any 24-hour period. The air conditioning there is really good, so I can't smell if nobody takes showers during the con, but I definitely take showers. Please take showers. Take more showers. That's not intended to be rude. That's just, I like showers. So what we like to do is we'll release patched services. So player 1 spends all of Friday solving service A, and by the end of Friday, they've got the service. They've got it nailed down. They're attacking it. They're getting points. That's cool. Service B comes out first thing the next morning, and they start working on it. Then halfway through the next day, we release service A prime, which may have the original bug patched, or it may have new functionality, or that one time we switched it from ARM to x86 because screw you players. And now player 1 has a choice. Do they abandon all their accumulated knowledge on service B, all the progress they've made, to go back to service A prime? Or does another player on their team that doesn't know how service A works start on service A prime? And that's a really, really interesting question and a really, really interesting choice for teams. And we want to make sure teams have interesting choices to make. And finally, sometimes challenges break. One of our 2015 quals challenges called Waiting for Your Touch. Our web guy wrote it, and that's me. It leaked database connections. And because Postgres has a limited size connection pool, especially when you cheap out on your Postgres server. And I got super stressful because one team scored it, so it was obviously kind of solvable, but it didn't last more than 2 minutes in the game before kind of slowing to a crawl and just giving everybody 500 errors. So I stressed over it. I tried to make a hot fix, and it just didn't work. So we decided, basically Gyno, the team captain, punched me in the shoulder and said, no, take that down. We'll unlock another service, and you can solve it at your leisure. Fix the problems, fix the leaks. And I'm really, really glad that he did that because our players got to have fun solving other services. And then when I brought it back up, more teams could score on it. And this is sort of the fundamental problem of building production services, is how do you manage your time testing it? If I test a service for 10 hours total, I put in 10 hours of testing. In a final service, if we want it to get tested in production for 10 hours, it takes 20 teams half an hour to put in this time on a service. For quals, 1,000 teams will rack up 10 hours of service time in 30 seconds. And there's sort of this how much testing can we afford to do before the service goes live? Or do we just assume it's going to work and hopefully not blow up in production? But then there's another perverse incentive in production. If a service goes down, if it's, denial of serviceable in production, that's really, really bad. Nobody can score on it. If the service that you thought had a memory disclosure vulnerability actually has a remote code execution vulnerability, that's actually a best case scenario for us, because teams just want to steal this flag. They don't care if they get it through memory disclosure or remote code execution. So if there's remote code execution and they can do it, that's cool. That's our perverse incentive. And that's sort of a big realization for me. And it involves understanding what teams are going through, having empathy for the players of the game. And the players of the game don't care about what kind of vulnerability it is. They just want to have fun. They want to hack computer software. And the only way that we've come up with this is by playing lots of capture the flag games. We know the kind of game we want to play. We don't want to lie to player, or we don't want to be lied to. We don't want challenges that require us to just guess. And we only got that after literally 10 years of playing these games. So whenever you're controlling challenge difficulty, the part of the challenge that's difficult, you have to make some choices. If you want to teach a player, you make it something that they have enough information to solve this. And we've sort of cheated a few times and had the first thing the challenge does when you connect to it, spit out the memory address of some buffer or something. And if the players can manage to land that, that's cool. If you just make them, jump through some ridiculous hoop or try it a zillion times, if players are brute forcing a challenge, that sucks for the players, and it's super terrible for the organizers, because now you're paying all this extra load for players that are just trying to solve it. So do what you can if you're building a challenge to not require a leap of faith on the part of players. Don't lie to players either. But if it'll make the game more fun, deceive the players a little bit, not a lot. And make it so that ideally your deception is a pun. And they're like, oh, I get it, you're super smart. You're using a pun. That's totally not the lowest form of humor. Trivia and memes, we actually got really tired of it. And so the standard, there used to be a trivia category. Ken Shoto super loved it. And the 100-point question was always blank the planet or hack the blank. Or one year it was hack blank planet. The only time we've ever done that question is whenever we've had to delete a service because it didn't work. And non-US teams, or teams that don't speak English as a native language, if you're doing the newest hot meme from Reddit, is it still that boy or is it something new today? If you're doing the hottest meme, they may not get it because they're not part of that culture. And it's not a test about cultural knowledge, it's a test about computer hacking. Writing a program to blast through a 2 to the 8th solution space is pretty fun. You can hit up and enter on your MacBook after fixing the challenge, or after fixing your script, and see if it worked. Doing something for 2 to the 16th is actually really, really bad. The imitation game about Turing breaking the codes in World War II. That was a big solution space that was too big for the computers at the time, but kind of frustrating for them. And you want to make the players a little bit frustrated, but not let's smash this thing with an axe and then drink a bunch of hemlock frustrating. Part of making the game fun is preserving player agency. If somebody anywhere has solved this challenge, no more hints. It's solvable without hints, you're done. Don't think carefully before you force unlock a challenge. You want the players to have fun and make choices about how they play the game. Think EVE Online. EVE Online, the space MMO, is fun because players can choose I'm going to take a cheap ship and then relabel it as a Tech 2 level ship and sell it to some rando hanging out in Uli and steal all their money, and the GMs will just say, well, you should look more carefully at what you were buying. It's a terrible game for a new player because you're going to be the victim of some scams unless you're super paranoid, and if you're super paranoid, you're going to spend your whole game time in Excel. On the flip mode, you have games that focus on player enjoyment, like WoW. We make sure to force unlock some easy challenges because of what happened last year. DEFCOR, the South Korean team that ended up winning, they solved a potent pwnable challenge pretty early in the game, and they solved this challenge and they unlocked the next harder one in this category that's not easy to begin with. And we lost a lot of teams halfway through the game because no more easy challenges or stuff that they could try and stretch themselves on were getting opened. It was just incrementally harder and harder binary challenges. And what we need to do better is make sure that easy challenges are open longer, because a new player isn't going to, jump into a 500 level binary thing. They may want a 100 level binary thing and a bunch of 100 level binary things that'll teach them something. It'll give them the confidence to do a harder challenge. And giving players confidence to have fun is really what this is all about. Hacking computers is inherently fun. Seeing how something works, seeing how it breaks, seeing what you can do to change how it operates. And the way we preserve that fun is by engineering a non-frustrating game. It's by operating a reliable game and having the empathy to make the game actually fun for players. So if you're curious, we have our qualifiers again coming up next weekend, and that font is way too small. But you can read more about it at legitbs.net. And I've got a few more extra reading here. But thank you, everybody. And I'm not above bribes. I have some A challenge coin for the best question and a bunch of dog tags for good questions. So have at it. Mm-hmm.
If you're just going to do online communities and trying to do these capture flag events, what's a good way of actually building a team?
So the question is, if you're just trying to get into these events in an online community, what's a good way to build a team? Is that a fair assessment of the question? So there's a security CTF subreddit where there are a lot of players or some players try and get little ad hoc teams together. But that's a really, really hard question. And I think we need to do a better job as a community of providing for pickup players. Our game, we basically require everybody to be on a team. And if you're on a one-person team, it's not a lot of fun. I don't have a super satisfying answer, but maybe it just comes down to knowing people online or hanging out in security-centric places online. I mean, NetSec is there, our NetSec on Reddit, the security CTF subreddit, but I don't know. I'm too far into the community to have a really satisfying answer for that. But good question. Thank you. What else? Yes. So the question is, do we worry about teams hacking our score bot? And constantly, and this actually happens to us, or has happened to us previously. The anecdote is more smoked leet chicken, or as they're known now when they team up with Balalaika crew, is LC Unicode Lightning Bolt character, BC. LCBC, get it? Their standard thing is whenever they've got an answer for a challenge, they get everybody in the room to type in the answer and hit submit all at the same time. And if you don't have, in our case, it's a unique index on the team ID challenge ID column in our solution table. They multi-score challenges. And they didn't even tell us about it in our 2014 game until like a month later when somebody was raging at us in IRC. It's like, you even let those clowns on More Smoked Leet Chicken score 4 times on that challenge. Did we? So we do worry about that constantly. And the unsatisfying answer is we make it against the rules to hack the scoreboard. What I suspect is more practical of an answer is we use a lot of database constraints to make sure that the correct constraint will keep them from multi-scoring a challenge in a Jeopardy game. And without admin level access to the database, they don't get it. At the same time, it's hard for them to do SQL injection because we're using Rails with active record and it parameterizes all the queries really nicely. But that is something we worry about. A lot of what we try and do is just monitor the game actively. If we get a lot of activity overnight when we're sleeping and the scoreboard changes drastically, we're going to investigate that. When we're on site, we have a lot more control over the network, and we can make sure that players only have access to the HTTPS port on the scoring system. They don't have access to each other after that one incident in 2013. In 2013, all the teams were on the same shared network, and we told most teams, it's like, you are responsible for your own network security. This is your IP address. And one of the teams came up to us halfway through Saturday and said, can you please tell so-and-so team to take their internal wiki off the public network? We're finished scraping it. But we do worry constantly about the scoreboard being hacked, and it's mostly just a matter of faith and monitoring. I mean, they don't sell safes that nobody can crack. They sell safes that are rated against a skilled lockpicker for X amount of time. And you have to have other security systems to make sure that a skilled picker won't have that amount of time. But very good question. Thank you. Mm-hmm. So the question is, and I'm actually trying to find the particular slide here. So this is sort of a lot of the themes that we've seen for challenges in the past: web, crypto, forensics, reverse engineering, programming, and shellcode. And we've done a lot of web and crypto in the past, but we've sort of tapered off recently. And honestly, it's because nobody on our team wants to write those challenges. A lot of people on our team have come up with a lot of interesting reverse engineering or shell coding or, just generic programming challenges. But the one web expert on the team, me, I don't have a lot of background in web exploits that aren't SQL injection or cross-site scripting or CSRF. And the latter two, as far as I can tell, they seem to require me to run another browser in a privileged position to get exploited. And I start looking at what is involved in running a challenge like that, and it's something where if I did that, or I could make the scoreboard a little bit better, put more interesting stuff in the scoreboard, or work on a crypto challenge, I feel like I could do that time a lot better. At the same time, for a crypto challenge, I'm not a super great cryptographer either. There's a crypto challenge I'm actually working on and off right now, and at this point, I would like it to be in the game next weekend, but I'm not expecting it to be. And it really comes down to, we don't have a really great reason. The reason is we don't want to. And because it's us running the game, we're fine with that reason. It's because I don't want to. And we also got over the fact that a Jeopardy board has to be square, where every category has the same number of challenges. That was the big one. Mm-hmm.
One last question. For theming and stuff like that, is there a good centralized area to actually, say how you don't want to do crypto or you don't want to do web? Is there good areas where you can actually start with almost like a template type of challenges and then re-tailor elements?
So the question is there like a place where you can say you don't want to do a challenge and start with a template, that sort of thing? So, and this may be like an unsatisfying pivot, but there's a GitHub organization called CTFs where they aggregate write-ups and whatever has been published about previous CTF challenges from previous years. There's a lot of great write-ups, and you can see what other teams have built as far as challenges go and what it took to solve them, take apart how they worked. And that's a really good place to see what a modern web challenge looks like. I've maybe been neglectful in going back there to figure out what a modern challenge looks like. But for us, we just communicate internally that if our big spreadsheet of challenges has nothing in the web category, that just means we're not going to do a web challenge. And that's really a lot of what we do isn't elite hacker stuff. It's this Google Doc and our Slack channel. And that's probably the most unexpected thing for me, is that it's such a social thing to build. It's not, heads down, let's, all fire up IDA. It's, we need to work as a team. Maybe a too much Disney movie, but. Mm-hmm.
You said that when you were running services in EC2 now, you have to tell the guys at AWS. What happened the first time?
So it's not so much something upset them the first time, it's that we had to communicate with them halfway through the game. So our first year running it, we didn't have a lot of money and we weren't sure how much we wanted to commit. So we ran literally everything in a micro instance. And with micro instances are really, nobody here is from AWS, right? So micro instances are really dissatisfying to use in production because at the time they didn't have guaranteed CPU. So you got to split your micro instance with whoever else was on the machine. If it was somebody's IRC bouncer and they're not visiting a super busy channel, nobody's pasting multi-screen ANSI art, it's probably fine. If you're sharing it with somebody's little website that a few people look at, if you're sharing it with us, that's terrible. And a lot of our services were just brought down by regular traffic, not even dedicated attacking. And with AWS, if you try and spin up too many servers, there's a point where they say, we need to actually validate that you're doing something okay with AWS before we give you more servers. So we do remain in contact with them, and we I guess, advise them that, yes, there's going to be a lot of what looks like attack traffic to these servers because they're being attacked. But there's nothing wrong with talking to AWS. Trail of Bits, they were doing the Cyber Grand Challenge qualifying event last year, and they call it a cyber reasoning system, but think of it as a robot hacker, basically. Needed a lot of machines, a lot of memory, and a lot of just CPU time to try and fuzz all these services. And their flamboasting on Twitter was that they reserved most of the compute instances in US East. And they joked that whenever the contest ended, the data centers got really quiet and the lights got a little bit brighter. And they didn't actually qualify for CFE. But it was interesting. And AWS wants to talk to you because they want to sell you server time. They really want to sell you server time. But good question. Thank you. Anything else? All right. Well, we've got 9 minutes now till the next talk. And I'm not sure what it is, but somebody with the schedule up can probably tell me. Thank you, and I'll put my contact information up one last time. And if anybody has any other questions that you didn't want to ask in front of the group, find me sometime this afternoon and probably tomorrow morning. Thanks, and have a good afternoon.